Okay, hello everybody. It is the time. We will give it just maybe a couple minutes because we're going to uh, introduce ourselves and talk a little bit. So we're still waiting for a few more people to come. We had a pretty huge registration, 130 people. And of course, most of those people do not come. That's usually the case. But that doesn't matter because you will be receiving the slide decks and you will be receiving the recording. So you will be good about this. Now, let me check everything. I want to make sure it's working. So if I go back to Zoom and I go on chat and I have the list of my participants, then could you please confirm that you can hear me okay? There you are. Can you hear me all right? Yes, okay, that is good. So that is our subject. I believe we will start. It's 12:02 Central Time. So we will start because the beginning is kind of introductory anyway. So here are the slides. AI for kids. Well, let us set the expectation. I'm just developing the course right now, but it seems to be very popular already. People started by telling their children about this, and I know that some kids also wanted to be on the line. So welcome everybody who considers himself a kid or herself a kid. And even my friend, I have a friend who is teaching as well. When his daughter heard about this AI for kids, she's 12. She said, "Oh, I want to be there. I want to be an AI for kids." So it started like a playful idea, but it seems to be going in the right direction. So there is a book on Amazon, but there's nothing like what I'm trying to do. Therefore, I'm going to show you what I'm trying to do here. And what I expect back from you is your reaction. Tell me, does it make sense? How was it? I'd like to teach it everywhere. I like to teach it in schools. I'm working on this with a friend who is from Africa, and he wants to teach in rural schools, giving the kids the advantage of knowing a lot about technology. And essentially, it's ready for everybody. So let's go. We said that it was AI for kids, and you can even learn it on your own. So maybe it will be a book. And my major goal is make it fun. If you're a mathematician, I am a mathematician, you may get absorbed into the formulas and pictures of numbers. And that really is distracting for those people who are not. Think of this. AI is artificial intelligence. And artificial intelligence means that somebody has the real intelligence, but right now we're creating kind of a same thing, but artificial. So you should be able to do it. You have your own intelligence. You shouldn't be a mathematician to understand AI. So that is the major idea. Ariel and Jeremiah are the kids who inspired all of that. And if we look at it as a course, which it will be, we're right now thinking about 2-3 hour course, then all you will need is internet. Right now, we have not come up with a way of packaging it into any kind of micro device that would not require internet. So for now, all you need is the internet. And we will not assume any knowledge. We will assume that the children are very smart. Children are sometimes smarter than adults, and especially today when they get introduced to all of those technologies very early. So these are the only assumptions that we have. And we can continue by saying that AI is something indeed that is for kids. So if you do this, if you teach kids AI, what do you think will happen? Well, you can talk about some obvious things. Here's build robots, fly drones, understand books, meaning that you will let the robots understand the books, or something else. So suggestions are welcome. But what we're doing here is an open experiment. Let's look at something like this. We'll look at Finland. But before we look at Finland, there is a definite benefit. Apart from knowledge that the children will get, and they will get knowledge. And maybe I should mention that I've been teaching for about 8 years now, that I myself have 6 kids. I taught them, and so I'm familiar with teaching the kids. So the one advantage to a kid to learn AI is that he will become quite popular. Today, as you can see in this picture, geeks are in. They are fashionable. And so basking in this unexpected popularity, that's what you will be as a kid if you're learning this. Today, it's okay to say that's what I'm doing. Today, it's okay to say I'm a nerd, I'm a geek, because that means you are cool. Okay, so that is the formal description of the course. That's what we expect, but we will see exactly what will come out of that. So let's look at one interesting company. This is Finland. Now, Finland is somewhere next to Russia, and that is somewhere in the northern part of the world. So that's a very pretty picture of Finland. But it turns out that Finland is a very interesting nation because it invented quite a few technologies, and it's very, very progressive. Well, first of all, what they've done is they have invented Linux, essentially a computer for today. And I hope everybody, even the kids, have heard about Linux, that it is a great operating system on which you can run anything that you want. That's step number one. Here's that fashionable hero, Linus Torvald, and he talks about how he is a real geek, a weirdo, and how he is also one of the 17 most popular people on the planet. And then he has lots of other things about him. He invented 35 things, patents, and there is even a little planet, an asteroid named after him. So here we talked about that he also invented other things, not just Linux. So that is the nation that we're talking about. That same nation invented chat, the very first chat, which here it looks like quite an ancient version of that, but then they redid it and it became whatever we use, all of the messages that we use on the phone. That was the first one. Actually, it turns out they also invented the first internet browser. At this time, the internet already existed. That was 1998, but the browser did not. So their browser was the most first. I'm not giving the name because that wasn't the well-known brand. Okay, and another amazing fact, they also invented Angry Birds. By the way, Angry Birds is a popular game. I hope everybody knows that. And it doesn't come easy. That interesting company teaches you something else. That was game number 50 that made it. So you work pretty hard. You release 49 products, and then product number 50 is what makes it. So that is the nation, but today something very interesting happened about Finland and AI. Being that they're obsessed with text, and here's a little story about personal things happening between the prime minister and his girlfriend and a text exchange. They are into all interesting new things. So it is a very small country, the population of just about 6 million. They decided to learn about AI and to become the leading nation about AI. You probably know that AI is driven by Google and Facebook and Microsoft and Baidu, to name just the very first 4. And that's the game for very big companies. But Finland is much smaller. So what they decided is we'll do an experiment that nobody else is doing. We will educate our population, everybody. The article about this talks about a 60-year-old dentist, and she wants to learn about AI. The way they did it was to engage all of the companies in Finland. And with the support of the companies, now they offered that kind of course to everybody in the country. Well, they didn't know what will happen. They did it just a year ago. At this time, you saw a little publication about Finland is teaching 1% of their population AI. And by now, probably it's already 2%. But something did happen. If you look at what happened by the end of 2019, then they decided, hey, we have a great course. And this picture represents exactly the open source, open for everybody course Moreover, you can do it in 24 languages. So whatever your language, very likely that there will be a language that you understand pretty well. So that's what happened out of one country, and who knows what else will happen. Well, the same thing here. We don't know what will happen with AI. AI is a big area of fear. Will the robot take my job away, right? And there are a few points of view. One of them is that no, it will not take your job away. It will help you do your job, which is the most optimistic. And quite enough serious people think that way. So that's what we will assume. We will assume that let's learn about AI, let's learn about robots who are our friends. So let's do this. We understood why we want to talk about AI, but now let's really talk about the AI. Now here, I will have to do a little drawing. You will see what I'm doing, but you will most likely not hear what I'm doing. So first of all, quick draw. I need to click on that link, and here's quick draw. What I will do is I will give you that link as well so that you can follow along. Here is the link for everybody who has the chat open here on the chat. First thing. There you are. This is quick draw. I'll say so. Quick draw from Google. So what will happen is that once I begin drawing here, it will tell me draw this. And then it will only give me 20 seconds to draw that. And it will be guessing. If you're doing this, you will hear that it is saying, I see a snake, I see a scissors, I see whatever it says. So let me try to draw something. Draw a bus. And of course, the pictures here are done by my daughter. She knows how to draw. I don't. So let us see, I quickly draw a bus.
I see line. I see diving board, or pillow, or keyboard, or bench. I see postcard, or spreadsheet.
Oh, amazingly, I got it. Well, I'm not going to continue, but I do recommend that you will continue and draw all these 6 drawings. It will only take you 20 seconds times 6. So it will only take you 120 seconds or 2 minutes. So I think it's fair to ask you to please draw that. Let's see. Somebody is saying something. You don't get the website in the chat. Just above, Sundar, just above what you said, there was this, but here's what you can do. I will tell you what it is. It says quickdraw.withgoogle.com. So I'll type it here again, because maybe that will get it to you. Oh, wait a second. It says I'm not doing it to everybody. That is why. How about this? That was sent to all panelists and all attendees. Now you should get it. Okay, that's great. So please, let's spend those 2 minutes and let us draw. And by the way, keep imagining yourself being a kid. Keep imagining yourself as somebody who is very curious, very interested, probably not that long span of attention. So we need to get feedback from that situation. And, you know, when you start being done, then please tell me I'm done. That way I will know that you are done and I will continue. Those people who are not done, they will continue drawing. That's fine. I just want a general indication of where we are. Okay, Gobinath is done. That is good. So good. How does it work? That's AI. So let me do this. Let me refresh. Go to the very beginning again. And see what it is. It's this is an AI experiment. You draw, it guesses made friends from Google, but then so far. Okay, I apologize. It seems like I had an interruption in the internet, but now we're all good, right? So this is the picture that we're looking at. This is about 50 million drawings that Google has accumulated. And that also tells you a secret of exactly how they work. First step is they collect all images. Initially, when they created this, they had themselves put to work and they were drawing little pictures. Obviously, people who are very much adept at that, they were first. So you can see pretty nice, very good pictures here. Here's an angel. All right, let's go back to our slides and continue with the structure. So that is a way to recognize pictures. And as one Google engineer put it, when I was previously looking and explaining how I'm looking for flowers, I was telling, well, I tell the computer to look around and I want it to see a word flower. Or maybe that word will be in part of the HTML coding and it will be a meta tag and it will say flower if the people are not lying. That was a little bit dull for the child. Now he says, with that kind of software, I just tell it, please look for the flower and it will find the flower. Well, exactly how does it do that? I'll show you a little later. My intent is to really go all the way and show you how the technology works. We're not just saying that's what you can do. We're saying that's how you can do it. So very good. That's the neural network that we'll be talking about. And these are the 50 million drawings. Some of them are very interesting. Like here you see a picture of a girl who is looking at all kinds of angels and she's thinking at, how can I do that? But Quick Draw that can do all of that. So that is important. Another important thing before we go into exactly how is the fact that this is a lot of data. That data is 50 million images. That makes Google richer than other companies because other companies do not have 50 million. Well, Google is nice. It usually allows you to download the data. It is sincerely interested in promoting AI everywhere, and so are other companies. That is the trend today. The knowledge is for everybody, and everybody can get it. It's only the question, those who want to get that knowledge get it. That picture shows that this data is the new oil, and that if you want to become rich, you collect data. Well, you also you also accumulate the knowledge of how to process that. Very good. So, well, how does it really work inside? Here's how it works. It will first ask everybody to draw all kinds of shapes, and then it will run a special software called neural networks that allow you to recognize a specific shape. Not everything in the world. You may notice that when you started drawing your sketches, then you didn't do this. You didn't say, I'm drawing something, and you Google guess what it is. No, it was more supervised. Maybe you didn't notice, but it says, draw a map or draw an umbrella. So all it has to do now is compare to all of the umbrellas in the world and see which is the closest to the umbrella. So that really is the whole secret. If you have a big enough computer, and if you don't have a big enough computer, then you just combine small computers together into one huge computer, to which there is no limit. So you tell it, well, tell me, is it closer to a brush or to an umbrella? And that's the whole story. How exactly can I ask, tell me, is it closer to a brush or to an umbrella? We'll come to that. But now we understand how Quick Draw works. Now, that is called supervised learning because I'm giving it a lot of examples of how I do it. And now I'm saying, well, computer, please do the same. This is supervised learning. This here shows you how Facebook made computers recognize faces. which by now is very standard. Of course, people who were born in, let's say, 2015, the minute they got their phone, let us say maybe in 2017, they already are used to the fact that, of course, Facebook recognizes this as Uncle Moshe. But to us, it's quite new. And so how did it work? Well, everybody takes their pictures, and then they also say, that's me. That goes into the Google repository, and Google runs a lot of recognitions, well, Facebook in this case, a lot of recognitions, but it knows who is who. Well, while Facebook was doing this, they did not know who was who, so they used a different device called Mechanical Turk. Mechanical Turk is a little bit to the side from AI, but it's found everywhere. For that reason, I'll just show you the picture of Mechanical Turk. Not the Amazon Mechanical Turk as yet, but a regular Mechanical Turk. Well, let's find it in images. That's good. That's a good image. So that story happened about 150 years ago, when there were no computers, I'm sorry to say, and then there were also no chess playing computers. And then somebody brought up a box, and that box said that I am a computer that can play chess. Well, that aroused some interest. It turned out that inside of that was a person. That person was dictating the answer. So that became popular. The person happens to be from Turkey. So anytime that you're only imitating AI, you're trying to pretend that it is a thinking machine, but really there is a human inside, and that's called the Mechanical Turk. So you saw here that there is such a service on Amazon. You can subscribe to that. You can say, tell me whose face is that by looking at his pictures that I'm giving you as well. Is that Mary or is it John? Given that I'm giving you a lot of Marys and a lot of Johns. So when you're building such a thing, you subscribe to Amazon and you send out those pictures and the people then work for you. That's how supervised learning is really trained and implemented. And the popular term here that I use is trained. That means that I'm giving a lot of data, lots of faces, lots of Helens and Rebecca's, and it knows who is who. Now, how exactly that works is shown in this picture. Now, guys, I'm taking you deeper. I'm going to give you that picture and I will explain what it means. That's a real neural network, but it's amazingly easy. So we go here and we're saying go to here, Playground Google TensorFlow. So I'll give you that link as well. Don't want to give extremely long link. All I need is the beginning. By the way, in the slides, all of these things will be given to you in the slides. So you don't have to look too much. Why it doesn't want to do this? Well, let's do another tab. So we're saying Playground. That's the link that I really need. So that's what I'm giving to you. Okay. And here it is on our chat. Oh, thanks for telling me. So that's because I was out and I wasn't sharing. Here it is, guys. Thank you so much. And sorry for all of that time. Well, the slides will replenish that loss. But we'll continue. We're here right now. And this is exactly how we recognize our pictures. Now that we can see the slides, we were right here. We were doing the recognition of faces. And by the way, I hope that that at least is what we were going through. And that is where we are right now. So here's the technology that enables it. Here's what you do. You tell the computer, well, here's a cat, here's a dog, here's another cat, here's another dog. In this case, all of them are represented by dots to make it simpler. But what you're really putting in is those examples that you know. The examples can be, I speak and I tell you what I mean. That could be an example. The examples could be faces. The examples could be images from QuickDraw. The examples could be those images. But in all of those cases, I'm giving it some examples. So here are my examples. And what I'm asking it to is to find the answers. I also give it the answers. So all I need to do is make that neural network come up with the answers that are exactly like mine. Here's an example. I know that I have orange people and I have blue people. And I want to distinguish when a new person comes in, I want to know, is he orange or she is orange or is she blue? So I'm given a lot of examples. In this case, there are 100 examples of orange and blue, and every person is described by just two numbers. How far is he on the x-axis and how far is he on the y-axis? So you can think of that as people jumping on maybe the chessboard, and we know that all of the orange concentrate in the bottom left corner and all of the blue in the upper right corner. But who can give me the formula, or who can give me a neural network, which I have not explained this yet, I remember. So who can give me a neural network so that I can see immediately who is who? That's who. So let me try to do this. I click on here and the neural network begins to train. And as you can see, it trained itself pretty well. Now, when we say train, what do we really mean? We mean that the neural network should read all of the thousands and millions of possible inputs and then learn or train itself to recognize them with the given outputs. Now, practically what it does is this. It connects every neuron to another neuron. For example, from the input, I go to this neuron. From there, I go to this neuron. What do those neurons do? The neurons just multiply my number. As you can see, I take that number found here, I multiply it by 0.-026. Then I take that same number and I multiply it by -0.15, and that I send to this neuron. Then I take the same number, it's becoming pretty dull, right? And I'm taking this number and multiplying it by 0.43, sending it to this one. Well, this is it. That's what neural network does. Initially, people investigated how does brain work, and it seems that it works very close to this picture. Well, by now, they recognize that this is a good picture and it gives us very good results. You can recognize cats versus dogs, but the real brain is more complex. Here, I'm showing just one neuron, and that neuron can only decide yes or no. I don't even need that many. I could just have one neuron. It would find the result just as well. There you are. It's a little bit slower because if your brain is smaller, then you think slower, but it still works. For more complicated data sets, let's look at a more complicated data set, like this one. Not that easy, right? For that, you would need more neurons. You can compare this to a voting situation. Let us say you have a lot of people and they vote on a certain proposal like, let us allow AI use the bathrooms, for example. So we can have multiple people voicing their opinions, and everybody will have their own opinion. So one neuron won't be enough to create a fair voting with multiple people. We'll need to add a lot, and that's what I'm going to do here. I'm adding more groups of neurons, and I'm adding more neurons here. So I have one group of neuron and another one, and maybe even more. These are called layers. Those groups of neurons, they're called layers. And I'm allowing to train. So let's do it. And you see, that's kind of a harder problem, but it's still solved by changing those numbers. So it is a lot of numbers to change. And if you want the computer to do this, you have to give him a lot of power. How do you give him a lot of power? I'll tell you a little bit later. Now, I didn't explain just one thing. So I said that you multiply it by certain number, send it to this neuron. What does the neuron do with all the 4 inputs? Well, it adds them up. That's what it does. It adds them up, but then when it comes out of here, it changes that number somehow. How exactly does it change it? This is controlled by here. This is called the activation function. And as you can see, there are a few functions that people found most useful and popular. One of them is mystical ReLU. So just remember that word ReLU, and later on we'll talk about what that means. If I use that function, then it will be a little different, you see. It has a little bit different shape, but it still works. So this is the essence of what happened in the world, that people thought of imitating a human brain for a long time. And first works and first papers came out 20 years ago. For example, the first work to recognize pictures and faces came out in 1998. But you didn't have Facebook at this time. You didn't have that many faces to learn from, and you also didn't have that many computers, because a neural network like that would have 6 layers with very many neurons in each. And so it would take a lot of time to change those numbers, and a lot of time is a few days. But they didn't have such computers. Now in 2015, 5 years ago, they did have that much computing power. And that is where they dug up the old paper. Well, the author was still working. So you didn't have to dig up the author, but they used his work, and there you got the face recognition perfect. That's all because people started using more and more computing power. That changed everything. And if you think that you never heard about AI up until now, up until maybe 2015 or 17, you're right, because there was not that much computing power to start imitating the brain. So that is still not connecting. Yes, I told you that is how it works, but what then? So let's go on a little bit more, and let's apply it to some practical purpose. So let us say we tell a computer a very popular competition. Some people like dogs and some people like cats. So, hey computer, please try to recognize, is that a picture of a dog or a picture of a cat? Now, in class, I would ask the children, how do they think a dog is different from a cat? But I'm not asking you this right now unless you want to type. What I'm doing instead is I'm saying, well, I will collect a few thousand at least pictures of the cats, a few thousand pictures of the dogs, and hopefully our neural network will start working and it will recognize who is closer to a cat, who is closer to a dog. Now, we humans, we make mistakes. I have a very pretty cat. It is a small gray animal that looks sometimes to some people like a monkey, and sometimes to some people like something they never saw. So we make mistake, computers make mistake, that's normal. So instead of telling us, yes, that is definitely a cat, we're not sure of our opinion 100%. We're saying, well, we're probably thinking that's a 90-95% a cat. That's the answer that the computer will give us. It will say, this is the closest to the cat, this is the closest to the dog. Now, well, let's really run it. I said that there will be a neural network. I said that we will be able to tell a cat from the dog, but I never showed you. This is how you would do it. So up until now, we were just playing. That is called the playground. We're playing with those neural networks to just understand how they work. But Google gives you something else. It gives you a Colab. And in that Colab, you can write code. So I think everybody knows what the word code means. That is the instructions to the computer on how to distinguish between cats and dogs, or really how to learn to distinguish between cats and dogs. And this is free. All you have to do is go to Colab Research, google.com. I'm giving you that link on the chat. There you are. And you can play with it. So anybody can do it in any place as long as he or she has access to the internet. And what you do is when you get there, you see this presentation. Again, it says only to all panelists. How so? I'm giving it to everybody now. Okay, now you all have that. So if you open that, most likely you will see this picture where you will be able to upload additional code right here. Read that code. It really stores it on your Google Drive. So you do need your account. You see it says that I'm logged into this account. So that's what we see. And then I would upload the code. Now to upload the code, you just do this. And there will be an upload tool. But I have already done this. So if I go to this place again, and if I see what I have already uploaded, then I have already uploaded a little lab that tells the difference between cat and the dog. And since we don't have all the time in the world, I have also run it. Usually, the computer learns to recognize the cats and the dogs by looking at the data, and that takes a long time. So first thing that I will do is I will tell you the computer, please be fast. For that I'm saying runtime where you run, change your runtime and make sure that it is a GPU. It is. Now you probably know the term CPU and GPU. That is a regular computer CPU and a computer for gaming, which is much faster, the GPU gaming processing unit. What you don't know is that it's a pretty expensive thing. Some gaming computers cost between, let's say, $3,000 to $6,000. Well, Google lets you run that for free. You see that I'm logging in, I'm not paying anywhere. Google even gives you a little other thing called TPU. So for now, let's just limit ourselves to saying that this is the most powerful processing computer, which they also give it to you for free. Very nice. So we're going to limit ourselves to GPU and run like that. Now, this is the code. This is what behind this. No, not this, but that, right? That was just a picture. Well, that's real. Now, I'll have to read it a little bit just to explain to you, but don't worry if you don't understand all of the code, because you usually don't start writing it like this. Instead, you're looking for a good example of doing something, like you want the software that will answer for you in the court of law. So you look for software for answering in the court of law. Here also, you will be looking for good software to tell the difference between cat and the dog. Now, what we're doing here is we're getting some cat and dog data, which we have already put on the cloud, and we're downloading this. The next step is I need to unzip that file. I need to get those cats and dogs out of the bag. That is what's happening here. And since I already ran all of that, that's why we don't waste any time. We just see the results. Then the next step is we can train the network. We're saying here is the data. So please train yourself and understand who is a dog, who is a cat. I will give you more cats and dogs, more pictures, and you will be able to recognize. Here's where it begins recognizing that. Here's some dogs. That's what the computer thinks are dogs. It doesn't know for sure, but it says that's the highest probability. For example, for that, he says the probability that this is a dog is 1.0. So there, he is completely sure, that computer is sure that yes, indeed, it is a dog, as you can see. Some are pretty complicated pictures, as you can see, right? But we also agree, that's all dogs. Well, let's look at something where it wasn't all that sure. Let's look at those pictures which were doubtful, like that could be a monkey behind the bars in the zoo, or no photo available, it didn't know. Or here, well, these are people. So it doesn't really think, they might look like cats, maybe or dogs, but no, we understand they're real people. So that's the case of that cat, for example. So that's the case where the algorithm wasn't completely sure, but it honestly told me that we're not sure. So that's how it can tell the dog. Can it tell the cat? Yes, here are some cats, and it says, I know these are cats. Probability is 1, that's not a dog. And as you can see, we would agree with that. And you see, it's quite smart about finding multiple cats. One cat obstructs the view of the other. So if you like cats, that's a pity, but it works. Now, were there some cases where the cats were not really cats and it wasn't sure? Let's look at that as well. Yes, that was something uncertain. I think that is a dog. I also think that's a dog. So that was the lowest probability of a cat. Okay, not perfect, right? We see it's not perfect. So what do we do next? Well, next we go and ask those data scientists. We absolutely need a cat or a dog for sure. And so the data scientist tells us you need more pictures, you need more training, you need more computing power. All of that is doable. Now, practically, if you're a kid and you want to do this, here's what you would do. You would email me and I would upload you, I would email you that text because that's what you really need. You need that code. So I will send you the code, you'll get it as an attachment in the email, and then you will go to Colab, Research Google, and upload that and run it. And then you would like to do something else. For example, you'd like to collect more pictures, not dogs and cats, but something else, something that you like, something that's useful. One of the useful things could be, is that your brother or no? Or something else, you will find out. So that is how you do AI, because what we're doing here is really doing AI. If we say that AI is whenever you know how to do it, you just want the computer to also know, then that becomes AI. So that's for pictures, right? And by now, pictures are very good. Everybody recognizes pictures. Facebook, it is a standard there. What we would like to do is understand what people are saying. So there are 3 major areas. One is understanding pictures. The other one is understanding what people are saying. And then there is a third one that understands what's going on. Because you want to know, let us say you have a few people, they're doing something around the truck is open. So are they loading this truck or are they unloading this truck? The only way to know is to compare a few pictures, few parts of the movie. So there are special neural networks that can do this. But we will look at one very specific neural network that is called BERT. Now, the reason it's called BERT is because BERT is a doll, as you can see, and you would say, well, is there such software as Ernie? Because that's also a doll, and it turns out, yes, that Google invented BERT, and that Baidu invented Ernie, and all of that you can also play with. Google itself plays with BERT today for about a year, and they use it to understand what you're saying. One of the examples of what they do is this. Let us say you want to ask, can I pick a prescription for a friend from the pharmacy? So if Google didn't use BERT and didn't understand what you're saying, it would just think you are talking about prescriptions at the pharmacy, show you the pharmacist, show you prescriptions, and maybe some illegal drugs as well. But today it understands that what you're asking is really in one of the most insignificant words, for a friend. And it will understand that, and it will exactly tell you the rules of picking a prescription for somebody else. Turns out, by the way, that yes, you can. So this is BERT. But what we really want to know is, how does it work? That's what we're doing here, AI. How does it work? Well, the answer is this. BERT works by doing what is called supervised learning. Up until now, when we were working with pictures, we said, well, give me examples of pictures and I will tell you what they mean. But please give me the answers. So here too, we're doing the same thing. We're letting BERT read all of the Wikipedia. And then we're letting it read all the books, all of the books in the world. Today, that is doable. And then we're saying, well, train yourself to understand the language. And BERT does this. It looks at the text and it removes some of the words, actually 15% of all of the words, and then it plays with the meaning until it replaces the words back. And it says, the word that I took out was a bucket, and I'm putting it back because by comparing all of the words around, I know that word was a bucket. So what happens when a computer can replace those words that you or he initially took out? What happens is that he gets some reasonable understanding of the text. It's a little artificial. He doesn't really understand. We do. So far, computers don't, and it's a big question if they ever will. But by playing and training themselves, they pretend that they do. So we're not going into this philosophical discussion, what is intellect and do we pretend to have it or do we really have it? But at least BERT trains itself by taking out the words and putting them back. That really is called self-supervised learning. And that's wonderful. You don't need any Mechanical Turk, which costs money, but you can do this kind of training for free. Well, the wonderful Google not only gave you the code that we saw before, but it also gave you the results of BERT reading all of the Wikipedia. So it is already pre-trained. It's similar to taking the computer to school and telling it will go through middle school, go through high school, understand what I'm talking about. The next step is we need to tell it some final task that it is going to do. For example, it's going to answer questions. This also is imitation. What we do is this. We take a BERT that went from middle school to high school and now understands English. And then we're saying, and now read this Stanford test with 70,000 questions. Remember all of them. And when somebody asks you a question, look that question up in the 70,000. You're a computer, you can do it. And it will try to understand it the best possible way, the way it's been trained. We just saw that it can understand the essence of the question. Find the right place in the Stanford test and then find the answer and give you that answer. So as you can see, it is a computer system, but it works. It turns out that that is what all the big companies are doing today. That is what Microsoft is doing. And if you look on CNN, you'll see all of those advertisements about, oh, we understand what you're saying, we understand it much better. So, well, you will tell me, can you do a lab? Can I try something like this? Let us try. What I have done is, again, I go to Google Colab. Let's go there. And I have run through a BERT lab like this, and I have uploaded it. My only real question is, did it run? Because you remember that it takes time to learn and read all of the books. So here, did it really run through everything you know? Well, I let it run. Let's see how far did it go. It collected all of the data that it needed. In this case, it learned English from the Wikipedia, but I'll give it a very specific task. I'll say, can you understand what the person is saying about that movie? And is he positive or is he negative? Did he like the movie or no? So let's go here. We will follow the instructions. We'll download all of the previously existing data, and that is hosted by Stanford. So now, in addition to that, we also get the data from the movie database. It's called Large Movie Review Dataset, IMDb. And we are getting this data and we're training ourselves to answer questions of that sort. Did he like the movie or he didn't? So that code you usually copy paste, you understand what you need to do. And in this case, you decide on some of the other things. Will I be taking these words out? Because if these are what is called stop words, there are too many of these, then I'll take them out. And sometimes I won't. That is something that is called fine tuning. I need to make sure that BERT is smart and working right. And then I let it train. It will be a lot of work. In the end, it should be doing this. It says, this movie was absolutely awful. So, was it yes or was it no? In this case, it found out, yet it was negative. It was pretty bad. The acting was a bit lacking. This is a very mild way to say that you didn't quite like the movie. So we're saying it's negative. It's not perfect, but it is not terribly negative. You can see that it is negative only in a small degree, like 1% negative, as opposed to here, much, much more negative. Okay, and then the film was creative and surprising. That is positive. What I could do now is I could create my own predictions. I can write something and I can run it here, right here, and try that. So I would have to go and start playing with this, finding where that was created, right? And then asking right here, I would add something else, and then I would ask Bert, well, what do you think? What did the guy say? Did he like it or no? That is the second lab that allows you to really try and play. And this is one of the most powerful AI today that we're looking at, that was invented just a year ago, already packaged by many companies, including Microsoft and including Facebook, to give everybody their fair share of praise. And all of these guys who are doing this, they're all friends. They all work on different things. So let me show you just a couple guys. Here's one of the chief guys there, and they're all called Jews, by the way. So here's Jeff Dean. Jeff Dean is the chief scientist at Google. Okay, and that's him. And he came to the city where I live, Houston, and he presented at the university, Rice University there. And he invented much of this AI. So there are lots of jokes about Jeff Dean. For example, Jeff Dean, when he writes an email, all other emails just stand aside. They wait till his email goes through. Or another thing, once the Google computer broke and nobody was answering questions. So Jeff Dean started answering questions instead of Google computer. And not only he answered all questions very quick, but the users like it 10% more than it used to be with the Google computer. Well, they had to relieve him of that because he needed to go home. That's Jeff Dean. Another, just one more interesting fellow that I will show you is the one who invented word to vector. He's also a very colorful personality. Thomas Mikolov. So let's look at Thomas Mikolov. And let's look at what he does. Okay, that's Thomas Mikolov for you. And what he invented was some of those wonderful text understanding ideas that came out of Google. Then he went to Facebook right now, and at Facebook, he's trying to create a very generic way of understanding so that it won't be another cat versus dog. He says, whenever you train cats versus dogs, that is essentially another cat versus dog competition. That's no big deal, guys. What you really need is a complete understanding system so that you just give it whatever the inputs are, and then it gives you the answers. And you don't have to program it again and again with your neural networks. But he's very far away in his research and is still looking at another 5 years. So these are the interesting people who are doing all of that, just to show you that it's fun, and you get to work with some very interesting kids that are doing some very interesting stuff. Now in class, I would also do a hackathon. Let's do something. Let's divide ourselves in teams, and each team will be working against another team. But for us, we're done. So now we have some time to answer questions. I think I see the questions and answers. Is anyone monitoring this? Well, that was my fault where you didn't have the slides. Okay, so here are the questions and answers. Let's see if there is anything on the chat. No, nothing on the chat. That's fine. You can always ask your questions later. You know where to find us. You just reply to that email that allowed you to sign up for the webinar, right? So if I go and check Then we have all of the people here, just that they're not saying anything, and we're good. So I'll give you a couple minutes. If you come up with any questions, good. If not, I will just wish you a very good afternoon. But please, please ask if you want the slides, you're welcome. If you want the recording, you're welcome. And if you want to say something, you're very welcome, because I really want to know, what do you think? Which kids would like it? What could we change so that the kids would like it? Okay, so thank you very much, everybody. It was a great rehearsal. Would we get the presentation video? Yes. Yes, you will, and that will be an email. You don't even have to do anything. You will get an email which says, here is your video. Next question, do you have to train BERT anymore yourself? That is a great question. You don't really have to. What you can do is use the existing BERT, and whatever answers it gives you is good enough. And that means you can look at technically we're talking about embedding, and embedding is a conversion from a word or from a little text fragment to a vector. So you'll get those vectors, they will be more precise than any other system gave you before. And then what you will do is you'll use them. For example, if you're looking for something that's very close to what you said, you can calculate the vector distances between all of the fragments that BERT has and your new thing, and you will say, well, that's what he's looking for. But a better way will be to find a way how you can train BERT to answer the last step. You will take the neural network as is, you will download it, you will load it into the neural network, and you will freeze all of the layers up until the last one. The last layer will be a fully connected neural network that will answer the questions. For example, there may be 70,000 questions, and you need to find which one you're closest to. And you would have to train it. For that, you would have to do the last step of training that will exactly do what you wanted to do. Where to learn to code like this? That's a great question, because everybody who sees this code, to me, they say, oh no, I cannot ever write this code. But the thing is that you don't. Usually with that kind of coding, you don't really write it from scratch. Instead, you take a tutorial. For example, what you would do is you would go find BERT tutorial, right? BERT tutorial. And it will come to you either on PyTorch, which is one of the libraries, or on TensorFlow, or today there is, I think, the third one called Hugging Face. It's a new interesting library. In any case, let's go with TensorFlow, which today is the most popular. And now you will see that code, you will copy it, you will upload it to, let us say, Google Colab, or you put it into your own, and you will start understanding what exactly they're doing. I'm trying to see where is the code, and then how can you change it? So you learn by first running it, then imitating the changes, and only then after that you begin changing it the way you want. Is that something that answers your question? Yes, you would get a presentation video, and you can also get the slides with all of the links, so either or. Okay, that's wonderful. So I wish you good luck. That's fun, as you can see, fun to work with those things. And so, well, tell us about your great results, okay, when you get them. I see some chat. The last question and answer. What's the intended age? Between 9 and 14, that's what my friend tells me who works with schools. According to him, there is a little issue. Below 9 requires a custodian or guardian, and that's a bit too hard. So he always goes from 9, and then to 14 he considers a kid, and he teaches therefore in schools, like in Houston. If you know Houston, there's Pearland, that's the area, and that is where he either teaches in schools, And he does all kinds of things. That's who introduced me to the idea. He teaches IoT, so he teaches a lot of things. He himself is from Africa, but he grew up in the States. He has a PhD from Boston University. That's the kind of things that we're doing and that he is doing. Right, Jose, thank you so much. Thank you. So I'm saying goodbye, everybody. Have a great weekend. Thank you, everybody.